In this video, we're going to explore the idea of stretching and compressing functions vertically. And the main idea here is just that if you've got a parent function and it's multiplied by some constant coefficient a, then the graph will be vertically stretched or compressed, right? So for instance, suppose that you have some function, f of x, which is a times a parent function that you already know, like x squared or the square root of x or x cubed or the absolute value. Depending on the value of a, the graph will be stretched or compressed, right? If the absolute value of a is greater than 1, then the graph will be stretched vertically, right? And if the absolute value of a is less than 1, then the graph will be compressed vertically, right? So that's the entire idea. So if the basic graph of x squared, is like that, a graph being stretched vertically means that, imagine that you're taking this graph and sort of pulling it to be taller. You'll sort of end up with this sort of taller, skinnier graph. Right? On the other side, if the graph is compressed vertically, it means that you're imagining this graph and it's sort of being squashed downward a little bit. And you'll have this sense that the graph is sort of wider or increases more slowly to the sides. Right? So that's the general idea of what this is. So I have a few examples for you, 4 functions here, and I'd like to know, for each of these, is it a stretch or is it a compression? Right? So pause the video for a minute, maybe try the first 2 of these, sort of check and make sure you've got them, and then finish the last 2. So for the first one of these, the a that we have is 2. Since the absolute value of 2 is greater than 1, it means that we have a stretch here. Okay. The next example that we have, the coefficient is 2/3. The absolute value of 2/3 is less than 1, and because of that, this will be a compression. All this is about is just looking at that coefficient. If the absolute value is greater than 1, it's a stretch. If it's less than 1, it's a compression. Alright, so if you didn't do the last 2 on your own, pause the video and try those on your own. So here we have a coefficient of -1/4. The absolute value of -1/4 is 1/4, which is less than 1. Because of that, this will be a compression. And the final one, we have we have -17 as our coefficient. The absolute value of 17 is most definitely greater than 1, which means this is a stretch. Right? So in all these cases, all we're doing is we're looking at the coefficient and we're determining whether this graph is sort of going to be taller, whether it's going to grow faster, or if it's going to be sort of compressed or squashed vertically, so that it increases more gradually as we go outward. So now I actually want to take a look at this graphically, right? So on this graph, I'm showing you exactly what f of x equals x squared looks like. That gives you an exact sense for how big x squared is, right? I now want us to sketch the graph of the function 1/4 x squared. And I don't want us to use a table, I don't want us to make this incredibly accurate. I just want a sense for, so what does this 1/4 do? And the idea is it compresses, right? It's effectively going to make this graph 1/4 as tall. So rather than being sort of this very steep curve, I need it to be sort of 1/4 as steep, right? So I'll sort of have a parabola that's growing outward significantly more gradually, right? And that's what I'm looking for. If yours was a little bit, shallower than that, that's fine. If it was a little bit steeper than that, that's acceptable as well. I'm just looking for the idea that because the absolute value of this is less than 1, my graph will sort of be shorter point by point. Okay. What I need to do now is I want to take this idea of, so what happens if we have a stretch factor like 1/4, but then we also have some translation factors like a -1 and a +2. Like what happens when we deal with those things, right? And I'm going to do that in 3 steps, right? Step 1, we remember the parent graph, which I've actually given to you. I've given you the absolute value graph. Step 2, we're going to draw the stretch or compressed graph using a dotted or a dashed line. And that's basically like what we just did, right? And then step 3, we'll translate that modified parent graph based on the translation factors, right? So we already have step 1. We've got our parent graph. If I hadn't provided that for you, you would have drawn, you're absolutely right, you'd have drawn a V, right? Next, we'll draw the stretched or compressed graph. So should this graph be stretched or compressed? Should it be sort of taller or should it be shorter graph? Well, because the coefficient is 1/4, because the absolute value of 1/4 is less than 1, this will be a compression, so we'll have a graph that is, and again I'm going to do a sort of dotted graph here. I'm going to do a graph that has the same V shape, but has been compressed vertically, right? So I still have that V shape, but it's a lot wider of a V shape. Now next, I have to look at these two numbers here, the -1 and the 2. What do those mean in terms of translation? Right? The -1 means something, and the 2 means something. I hope what you remember is that the -1 means the graph is translated to the right 1 unit, and the 2 means that it's translated up 2 units. Right? So the idea is we're going to take that sort of squashed V graph that we have here, and I'm going to translate it right 1 unit and up 2 units. So right 1 unit, 2 up units, sort of going to start from here, and then I'll have my shallower V going in both directions. And that's not a very good V, but we get the sense of what this graph should look like, right? We still have the V shape, but it's been compressed vertically, right? So the idea here is we do the compression first, then we do the translation. So I'd like you guys to maybe try this one on your own. Step 1, we've remembered the parent graph. Second, we want to sketch this compressed graph or expanded graph. Think about this coefficient and what that will mean. So pause the video. At the very least, try step 2. Try, writing in what will the stretched or compressed graph look like. Well, because the absolute value of -2 is greater than 1, this will be a stretch. But it is -2, and so it'll be a stretch that's been flipped across the x-axis. So what I'm going to do is I'm going to draw a parabola, a sort of a dashed parabola, that increases a little bit more steeply than the one up above did, right? So I've got a parabola here that's a little bit steeper, and I might sort of make this side a little bit, maybe even a little bit steeper. Great, so that's a sense of what this is going to look like. Next, what's the deal with this translation? What does each one of these added terms do for us? The 3 is going to translate us to the left by 3. The 1 is going to translate us up 1. So we'll sort of imagine that this, upside down parabola that I have gets shifted left 3 units and up 1 unit. That's going to be my vertex. And then I will draw my steeper parabola from there. Again, these are not intended to be incredibly accurate graphs. We're just looking at a sense of what these graphs are supposed to look like.